All right, guys, so this is the video to 4.3 part 2. So in 4.3a, we learned how to divide polynomials using long division. And for most of you, this is a pretty torturous process, but it does work, and so that's good. But today we're going to learn it's a shortcut. So the good news, it's a shortcut and it's far easier than long division. The bad news is that it doesn't work all the time. Okay, there's special cases when it works. Okay, so as we see here, we're going to call this synthetic division, and it only works when we're divided by polynomials in the form of x minus k. Okay, so in other words, if we're dividing this by x squared plus 3x whatever, we could not use it. But because we're only dividing it by x minus 3, we can. Okay, so notice my k value here is positive 3 because this is x minus k. So we want this to be a negative. So my k value here is 3. So I write it kind of different. Okay, so I'll write the 3 out front, and then I'm going to do like a division upside down kind of, I don't know, or maybe an L. You can look at it this way. Okay, and what I want to do is I only want the coefficients of each of these terms. Now, you have to have this in standard form. And because there's no x term here, I'm actually going to rewrite this as negative x cubed plus 4x squared plus 0x plus 9. Okay, so this and this are the same thing. I just added this 0x. And the reason I add that 0x is because when we do synthetic division, we have to account for every term in this polynomial. And if we skip an exponent of x, we have to count that with just a coefficient of 0. Okay, so the coefficient here is negative 1, then we have 4, then we have 0, 9. So we're going to write negative 1, make a little space, 4, make a little space, 0, make a little space, and 9. Okay, now when we do this, I always just bring this first number down. This first number doesn't change. Okay, now what I do is I'm going to multiply 3 times negative 1, so that's negative 3, and I'm going to put the negative 3 right here. Okay, and after I put that there, the number that goes below, I just want to find the sum of these two, so 4 plus negative 3 is just a positive 1. Okay, so once again, I'm going to multiply 1 times 3, that's 3, and I'm going to put the 3 here. Okay, and then when I add these two, 0 plus 3 is 3. And then I'm going to multiply 3 times 3, which gives me 9. And when I add these two, it gives me 18. Okay, now I always work backwards here. Okay, so our last term, this is always our remainder. Okay, the next term, we're just going to work backwards. This is our constant, or our number without an x value. Before that is just our x, and here this is the coefficient of our x squared. Okay, so we can write this, we divide negative x cubed plus 4x squared plus 9 by x minus 3, we would get negative 1x squared, or you could just write negative x squared, plus 1x, or just x, plus 3. And then if 18 is my remainder, you can remember that we write that as plus 18 over whatever we're dividing by, which is x minus 3. So this would be your final solution here. Much quicker than long division. All right, let's look at example 2. Now I'm going to help you set it up, and then I want you to try it on your own. But first of all, I want you to notice that we're multiplying this by an x plus 1. And remember, we want this in the form of x minus k. All right, so here, we're actually on the outside, we're not going to put a positive 1, we're going to put a negative 1. If that confuses you, think of x plus 1, that's the same thing as x minus a negative 1. Okay, that's why I put that there. So that's what's going to go on the outside. Okay, then on the inside, we're going to have the coefficients. So we have 3x cubed minus 2x squared, positive 2x, and then a minus 5. Okay, so go ahead and pause this, and from here, try to go ahead and find the answer to this problem. All right, so this is what you should have gotten. Now, as you remember, we just bring the 3 straight down. 3 times -1 is -3. And then we find the sum of these. So -2 plus -3 is -5. -5 times the -1 is a +5. And then 2 plus 5 is 7. 7 times -1 is -7. And we get a remainder of -12. Okay, so we're going to work backwards. This is our remainder, our constant without a variable. This is the coefficient of the x. This is the coefficient of the x squared. So if you put all that together, this is our new polynomial. Now, I do want to note that when we add a negative, and I'm not sure which way Big Ideas wants it, but this is the same thing as 3x squared minus 5x plus 7 minus a 12 over x plus 1. Okay, I'm not sure if it's a big deal for Big Ideas, but either one of these are the same thing here. If you feel like you need additional practice, please go ahead and pause this video and work these 2 out, and then I'll come back with the answers. If not, go ahead and skip and go on to the next part. All right, so this is what you should have gotten on these 3 if you work through them. All right. So next thing we're going to talk about is the remainder theorem. And this, like a lot of things in math, will make more sense once we do an example and talk about what it means. But this is just something else that synthetic division can help with. So if we divide something by x minus k, now remember this is the only time that we can use synthetic division. But if we do that, remember, we find the r, the remainder, and the remainder is what actually is f of k. Okay, so right now this probably doesn't make much sense, but once we do an example, it will. All right, if I look at example 3, okay, we want to use synthetic division to evaluate f of x equals, here's a polynomial, when x equals -4. Okay, so if I know x equals -4, what I want to do is I want to find the remainder when I have -4 out front. So just the same as what we did before, synthetic division. So 5, a -1, 13, and a 29. Okay, so the 5 goes straight down. Okay, 5 times -4 is -20. -1 plus a -20 is -21. A negative times negative is a positive, and this is what? 84. And if I add these, that's 97. And that's too big to do in my head anymore. So 97 times -4 is -388. And if I add 29 plus -388, you get -359. Okay, so really the only thing we're worried about here is this remainder. Okay, the remainder is -359. Okay, that means that in this function, f of -4 has to equal -359, at least as long as we did our synthetic division correctly, it does. Okay, so if we plug in -4 into this equation, so 5 times -4 cubed minus -4 squared plus 13 times -4 plus 29, if we do that, this will equal the remainder. Okay, if you don't believe me, put it in your calculator, double check it. It's actually pretty darn cool. All right, so here's just another more examples if you want to practice that remainder theorem. So if you do, go ahead and pause this video, work these out, and then I'll show you the answers. If you're good and you're comfortable, you can go ahead and start on homework. All right, so this is what you should have gotten for these 2.